Hello, my name is Corey Mabry, and this summer I worked with Dr. Adam Hansel at Susquehanna University to assemble a Muon-Specific particle detector. Getting started, I had to do a bit of research about cosmic rays in general. A cosmic ray is any collection of particles that penetrate our atmosphere from space. These streams of particles that are emitted by celestial bodies, such as stars or nebulae, contain most notably free protons or helium nuclei. When traveling at relativistic speeds, these particles carry enough energy to kick off a series of events that result in a particle called a muon making its way to Earth's surface. For a muon to be created, one of these cosmic particles must interact with a molecule in the upper atmosphere, and when carrying enough energy, a collision between the two particles will cause the stability of either to falter, initiating a reaction that yields a meson. A meson is a classification of particles defined by having an even number of quarks, usually a quark and antiquark pair. Most commonly, the mesons yielded here will be the pion or the kaon. Pions are unstable particles with very short lifetimes, meaning they will decay quite quickly. Charged kaons are known to decay into a muon-muon neutrino pair, pion, or even both. Charged pions are then known to typically decay into a muon with its paired neutrino. This is where most of the muon flux on Earth comes from. The muon itself is an elementary particle in the lepton family, meaning it does not seem to be composed of any other things. The muon is a sister particle to the more commonly known electron, both being leptons, and carries the same charge with about 200 times greater mass. This greater mass gives it a stronger penetration power, which allows it to be detected a bit more exclusively without interference of other subatomic particles. The goal of our research is to eventually optimize the production process and make muon detectors more easily accessible and usable for anyone wishing to expand upon the project. However, we don't stop there, as we also want to expand upon the project ourselves by introducing different materials into the equation to see what kind of manipulations in the reading we are able to force. Once content, we wish to build a whole wall of these to show us a longer trajectory of the particles in question. The detector works by using a block of plastic scintillator which produces a photon when penetrated by a charged particle, in tandem with a silicon photomultiplier to send a readable electrical signal into an Arduino Nano. The Arduino is coded to show us the received signal in a way that makes sense for people to read. This summer, after soldering several hundred pins of a printed circuit board, I was finally able to connect a scintillator and a photomultiplier to the circuit board in question and create a complete detector. However, this first one came with a little troubleshooting that as of now is unsolved. The project is to be continued and hopefully will be up and running very soon. Thank you for listening.